Okay, quiz 16.2 is just a ton of practice with pH and POH calculations. And so for the first question, we're asked to find the pH given the following values of H3O plus concentration. And we need to remember that the pH is equal to the negative log, and that's a base 10 log. If you're using Wolfram alpha or something like that, you might need to make sure that you put a log 10 function. On most calculators, the base 10 log is just the log button, and then the base e log or the natural log is the ln button. Anyway, so that's a base 10 log of the H3O plus concentration. For the first one, we would say the negative log of 1.5 times 10 to the negative 3, that's going to equal 2.82. And I don't know that it's necessary for me to reproduce this equation. I'll just give you kind of the answers to the next three. For 3.7 times 10 to the negative 8th, it's 7.43. For 4.6 times 10 to the negative 13th, it's 12.34. And then the last one, 9.2 times 10 to the negative 2, that's fairly acidic, a pH of 1.04. And I will remind you that all of these numbers have two significant figures. The numbers after the decimal are considered significant. The numbers in front of the decimal are not. In fact, there are fancy names for these. This is called the characteristic. And then this one has a great name. This is called the mantissa. So now you can impress your mathematician friends that you know the lingo regarding logarithms. The characteristic essentially tells you the magnitude or the power of 10 that this number represents. And then the mantissa is like the actual digits. So in other words, just like we don't count these as significant digits, they're just a representation of the power of 10. That becomes a part of the characteristic. And then these are the real numbers. They become a part of the mantissa. There you go. That was more math theory than you were expecting, but now I've answered hopefully all your questions about sig figs and logarithms. So question 2 says find the H3O plus concentration for given values of pH. Let me erase all this. We're doing the inverse. Now we know that H3O plus is equal to 10 raised to the power of the negative pH. So you'll want to find the little button on your calculator that's going to be like that, 10 to the x. That's how you'll do this. And so if I have a pH of 2.71, then I'm looking for 10 raised to the negative 2.71. And again, we've got two sig figs here. It works the same in reverse. Two sig figs in this pH, and so we'll want an answer to two sig figs. And that's going to be 1.9 times 10 to the negative third molar. And again, I won't reproduce the equation for all of these, but the next one, pH of 7.64, that's going to be 2.3 times 10 to the negative 8th molar. And pH of 9.45 is going to be 3.5 times 10 to the negative 10th molar. And a pH of 13.24 is 5.8 times 10 to the negative 14th molar. Okay. The next question is just to give you practice in sort of navigating all of the different ways we can do these conversions. So remember, in addition to what we've just done with pH, we have equivalent relationships for the pOH and the OH minus concentration. And so I won't write them up, but they're exactly the same. They have OH instead of H plus. Then we also have the Kw, that's equal to 10 to the negative 14th, or 1.00 times 10 to the negative 14th. And that is equal to the product of H3O plus and OH minus. And so we can use that to find either of these concentrations if we don't know the other. And then we can say kind of the pKw is equal to the pH plus the pOH. pKw is the negative base 10 log of Kw, which is a nice number of 14, is equal to the pH plus the pOH. And so these two relations, I won't redraw it here, but remember I had that sort of box of conversion factors in the lecture for section 16.4, where we had H3O plus and OH minus and pH and pOH and all the ways to navigate between them. So that's all we're doing here with this table. And I'm not going to work all of these in this video because it would just use a lot of chalk and be a little bit tedious. But I'll work like the first half of the table for you. And then, the PDF key is posted and you can just double check your work on the rest of them. You see, I don't have to do the tedious stuff. You have to do the tedious stuff. Well, actually, I did too. I made the key in the first place. So anyway, so what we have is H3O plus and pH and OH minus concentration and pOH. And I'll just do the first half of this. So is that all going to fit? It is. And so we're given some values here, 1.3, 3.86, 7.3 times 10 to the negative 4th, and 6.32. And I like to start to fill in the easiest parts first. The pH to pOH calculation is the simplest. I just take 14 minus the pH to get pOH. What's 14 minus 3.86? It's 10.14. And I can do the same thing here. 14 minus the pOH will give me the pH. So 14 minus 6.32, that's 7.68. And then if I have the pH, I think it's easiest to go from pH to H3O plus. I don't need to use the logs. I just feel like it's a little bit easier. So I'll just say 10 to the negative 3.86. What's 10 to the negative 3.86? 1.4 times 10 to the negative 4th. And now finding the OH minus, I'll take 10 to the negative pOH. I think that's the simplest way to do this. So 10 to the negative pOH, 10 to the negative 10.14 is 7.2 times 10 to the negative 11th. And I'll do the same thing here. 10 to the negative pOH is going to give me 4.8 times 10 to the negative 7th, and 10 to the negative 7.68 is going to be, where am I? 2.1 times 10 to the negative 8th. Okay, well, these ones we don't have pH for, so we'll just do it the hard way. I know that 10 to the negative 14th is equal to the product of H3O plus and OH minus. And so I'll take 10 to the negative 14th and I'll divide it by 1.3 to get 7.8 times 10 to the negative 15th. And I can do the same thing here. 10 to the negative 14th is equal to the H3O plus times the OH. So I'll take 10 to the negative 14th and divide by 7.3 times 10 to the negative 4th. I get 1.4 times 10 to the negative 11th. And now I'll take the negative base 10 log of 1.3 and I get a pH of negative 0.11. And I'll take the negative log of the OH minus to get the pOH. So negative log of 7.8 times 10 to the negative 15th, and that's 14.11. You'll notice these still obey the, these two add up to 14 rule. Everything should be consistent in that way. And I really included this first example to prove to you that pH is not bounded by 0 and 14 in any way at all. You can have pHs that are lower than 0 and greater than 14. 7 is the middle, but it could theoretically go on in both directions infinitely. Okay, there are practical limits. You don't often get pHs less than 0, but you can. Okay, and we'll take the negative base 10 log of 1.4 times 10 to the negative 11th. That's a pH of 10.86. And the negative base 10 log of 7.3 times 10 to the negative 4th. pOH of 3.14. Okay, so I want you to be very fluent in these relationships and these equations. I want you to know where on your calculator you can find the base 10 log and the 10 raised to the power buttons, as well as the natural log and the exponentiation button, e raised to a power. Know the difference, know when to use the correct ones, and to know how to strategically solve a problem in the simplest way. Like, I think it's a lot easier to find the pOH from the pH. And to go from pHs to concentrations to me seems a little bit easier as well. All right, good luck.